Hello everyone, here is Teacher Chen from Kangaroo Study. Today I will bring you a challenge question. In this figure, what is the length of AF plus AG? Let's see the question together. In triangle ABC, given that AB equals to 180 cm, AC equals to 200 cm, DF are points on AB and EG are points on AC. If we connect CD, DE, EF, FG, the triangle ABC can be split into 5 smaller triangles with equal area. What is the length of AF plus AG in centimeter? In order to solve this question, we need to calculate AF and AG separately. Before we calculate this, let's go to review what is the formulas to calculate the area of triangle. Is base times height divided by 2. But in this question, besides the base AB and besides the base AC we don't know any other base and we don't know any other height. Using these formulas to calculate this question doesn't work in this question. What can we do? We can find that these 5 smaller triangles are adjacent to each other. What is the characteristic between them? Let's see an example. In example 1, in triangle ABC given that BD equals to CD, what is the relationship between triangle ABD and triangle ADC? This question can be also considered. Here is a big cake ABC and 2 people want to share it equally. So we cut from AD. Then why is this 2 triangle ABD, ACD, this 2 cake area is the same? How to prove it? Can we use the formulas to prove it? Definitely yes. Let's see in the triangle ABD. If we take BD as the base, where is the height? Let's make height AE. Then how to represent the area of triangle ABD? Is BD times AE divided by 2. And similarly, let's make the height of the triangle ADC if we take CD as the base. Whoa, what can we find here? The height is also AE. Then how can we represent it? The triangle ADC is AE times DCD divided by 2. And we can observe that these triangles share the same height, so AE equals to AE. And the question told us that BD equals to CD, so we can go that BD equals to CD. Then, can we prove the triangles are the same? Definitely yes. So the area of triangle ABD equals to the triangle ADC. Let's look at another example. In triangle ABC, given that the ratio of BD to CD is 2 to 3, what is the ratio of the area of triangle ABD to triangle ADC? This question can be also considered. Here is also a big cake ABC, but this time, one person wants to take 2 pieces of this cake. The other person wants to take 3 pieces of this cake. We need to divide this cake into 5 pieces. Let's divide it. And each of the pieces, their area is the same. So they are 1 unit. Then how many units in the triangle ABD? We can find that we have 2 units in the triangle ABD. Then how many triangles we have in ADC? We have 3 units. Then can we get the ratio of the area of triangle ABD to triangle ADC now? Is 2U to 3U is 2 to 3. We can cancel the U. And in this question, we can also find if we take BD as the base, CD as the base, where is the height about these 2 triangles? Oh, it's also AE. They share the same height. If they share the same height, the triangle's area is only related to their base. And we can also find that these 2 triangles share the same vertex A, and their base BD and their base CD is on the same straight line. Let's make a summary here. All this type of model we call the equal height model. And if we can get that the area ratio is equal to the base ratio. And what is the characteristic between the triangles? So first, they need to have the common vertex, and the next, their base should be on the same straight line. Okay, then let's see the example 3. In triangle ABC, given that the area of triangle ABD is 50 and the area of triangle ACD is 30, what is the ratio of BD to CD? So here, let's mark it into the figure, 50 and 30. And we just discussed before the area of this triangle is how can we represent it. Let's make the height first. In the triangle ABD, if we take the base BD as its base, the height is AE. And in the triangle ACD, if we take CD as its base, we can also find the height is also AE. So how to represent the area of triangle ABD? Is BD times AE divided by 2. And similarly, the area of triangle ACD is CD times AE divided by 2. And they share the same height, so their area is only related to their base. BD to CD is 50 to 30 is 5 to 3. We can also make a summary here. This model is also equal height model. If we know the area ratio, we can also get the base ratio. Okay, are we clear about this? Let's back to the question. Is that can be split into 5 smaller triangles with equal area. Let's label it equal. Each area is 1 unit. Then we need to find the length of AF plus AG. Let's calculate the AF first. We can find that the AF is on the side AB and the side AB is inside the triangle ABC. Let's see the triangle ABC first. Then it's also like a big cake. Can we cut it into 2 parts? How can we cut? How to find the line? Oh, very good observation. We can find the line CD to cut it into 2 parts. So, what is the area of triangle BCD? It's 1 unit. And how about the triangle ADC? It's 4 units. Then we already know the area ratio. Can we find the base ratio of BD to AD? Oh, it's 1 to 4. 1U to 4U is 1 to 4. So we already know the ratio of BD to AD, and we know that AB's total length is 180 cm. Can we find the length of AD now? It's 180 divided by 1 plus 4 and times 4. So it's 144 centimeters. We already know the length of AD, but we need to find the length of AF. What do we need to do next? Oh, we need to find the equal height model again. So we can also find that the length AF is on the side AD. And we can find that the EF divided this triangle AED into 2 parts. What is the area of triangle DEF? It's 1 unit. How about the area of triangle AEF? It's 2 units. Then can we get the ratio of DF to AF now? It's 1U to 2U is 1 to 2. Then can we got the length of AF now? Is 144 centimeters divided by 1 plus 2 and times 2 is 96 centimeters. We already find the length of AF. Now we need to find the length of AG. Let's see. The AG is in the side AC, and the side AC is on the triangle ACD. Then let's see the triangle ACD now. How can we cut this cake into 2 parts? Oh, we can find the side DE, cut this into 2 parts. What is the area of triangle CED? Is 1 unit. How about the triangle ADE? Oh, it's 3 units. Then what is the ratio of CE to AE? Is 1 unit to 3 units is 1 to 3. Then Can we got the length of AE now? For we already know the length of AC is 200 centimeters. So AE is 200 divided by 1 plus 3 times 3. So the answer is 150 centimeters. We already know the length of AE, but we need to find the AG. What do we need to do next? Very good. We need to find the equal height model again. This time, AG is also on the length AE. And the length AE is inside the triangle AEF. So this time, how can we find the line cut this cake into two parts? Or is the line FG? What is the area of triangle EFG? It's 1 unit. Then how about the triangle AGF? It's also 1 unit. Can we get the ratio EG to AG now? It's 1U to 1U is 1 to 1. Then we can get the length of AG. It's 150 divided by 1 plus 1 times 1 is 75 centimeters. We already know the AF length. We already know the AG length. Can we get the final answer now? Very easy. It's 96 plus 75 is 171 centimeters. So here is the final answer. And today I also bring you a practice problem. After you have done these questions, you can post your answer in our comment section or private message to me. We can discuss this question together. And if you want to know more about our Kangaroo study, you can just scan this QR code, contact us. If you like our videos, please give your thumbs up and subscribe to our channels. See you next time. Bye bye.